Hello, good morning, Irfan.
Morning, madam.
How are you today?
Fine, thank you.
Fine, thank you. Okay, before let us begin with our class, I would like to share a short story. Like every time, I used to share a puzzle, a riddle, and sometimes I used to share and trouble you with riddles. So today, let me start off with a short story. Before coming this morning, I had an incident. I got through an incident. You all know what was it? Okay, so I was driving my way to school and I saw this little boy on the way. And what was the little boy doing? He was holding his dad's hand and standing down the way and waiting for a public transport to come. Maybe waiting for a bus or maybe waiting for a taxi. But when I saw that little child, when I saw that little guy over there, a small little child, I could feel he was scared, but also he was very happy because he was holding his dad's hand. And I could feel that he was feeling very safe down there. Then I drove across the school, the primary school that was on the way before we reached Central. There's a school. And over there, I saw this girl. She was holding, again, her dad's hand and walking very safely and quietly. And you know what came in my mind? Why are these little kids holding their dad's hand? Why aren't they walking alone? What is so special and so nice to be beside your father? Do you ever think about it? You, dear students. And do you know why I'm sharing the story with you? What's this Sunday? It's Father's Day. I think you guys forgot about it. Even I forgot about it. Until my dad called and he's like, oh, do you know what's this weekend? And I'm like, oh yes, it's Father's Day. And you know what I realized seeing kids like that today on my way to school? That if you have parents in your life will be simple. Whether you are in class 3, if you are in class 4, you are in high school, year 13 students, or whether you are a teacher like me. Great. So that's a message for you today. Today's class, our short motivational message is you go back and tell your dad how you feel about that. And if you don't have a dad, don't be upset about it. Go and tell your mom. Your mom stood by your side as your dad when your dad wasn't there. Great. Now, where did we leave behind in our last class? Do you still remember?
Coulomb's law.
Coulomb's law. Let's recap about Coulomb's law. We were supposed to cover about Coulomb's law today, but in last class we just had a brief look into Coulomb's law. We got introduced to electrostatics. What is electrostatics? Do you still remember from year 12? Electrostatics. Come on, I give you 2 minutes to brainstorm. Give me ideas about electrostatics. And don't forget, in our previous class, we did discuss a little bit about electrostatics. And I did tell you that today we will be introducing to Coulomb's law. Reintroducing. You already know about Coulomb's law from year 12. 2 minutes, discuss in the group. What would I say if I was at your point? Let me recall when I was in high school. Electrostatics. What I used to do is always break the words apart. Break electro and break statistics. Or statics. So, how would you break it apart? What does electro means to you, Michelle?
Electricity.
Electricity. Very good. How about statics? Do you think static is something that is at rest or is at motion?
At rest.
Okay. How about you? Good question, right? How about you go and do proper research? Give me the definition of static and dynamics. This will take you back to kinematics and will also take you back to motions. Right? You can go back and do this research because today we have shortened period, unfortunately. There is an assembly, and because of that, we will just stick to the basic terminologies. But this is your homework, and I want you to come and present up tomorrow. Find about it, read about it, and go ahead and find the real life applications to it. I'm pretty sure your friends don't know about it because the class seems to be very quiet today. Or was it just my story early morning, making you emotional? Seems like. Okay, so since before the start of the class, our friend over here did talk about Coulomb's law. Do you want to elaborate more on Coulomb's law? Just from year 12 and year 11. Do you remember Coulomb's law? Who is this person? What did he create? And what is meant by Coulomb's law? From your year 12. I wasn't your year 12 teacher, but your year 12 teacher did tell you something about Coulomb's law. Didn't she? Whenever you hear this word, Coulomb's law. Because as soon as I said electrostatics, before that you jumped into Coulomb's law. That means electrostatics is defined by Coulomb's law. What is this Coulomb's law?
Coulomb's law is force is equal to
Okay, you are saying force is equal to, maybe you want to write it for me? Come ahead. Just write the mathematical expression. You don't have to write the whole definition. Great, very good. Would you like to explain this to me, my dear? What did you write? In terms of words. Any ideas? What can you see over here? There's F. What does F mean in physics?
force.
Good. It means force. And since we are under electrostatics, this means?
Electrostatic force.
Right, electrostatic force. Very good. Now, what does this Q mean?
That's
Charge. Excellent. What charges are we talking about? It could be either
electrons or protons.
electrons, protons, very good. And electron, protons, what are the charges they have? Positive and
Negative.
negative. Which one is positive, which one is negative?
Protons is positive.
Great. Protons are positive and electrons are?
Negative.
How about neutrons? What do you think neutrons are?
Neutral.
What does neutral mean? What does neutral mean? Does it have no charges?
Yes.
Okay, someone said yes. How about others? Do neutrons have no charges at all?
Yes.
Sure about it? Pretty confused, aren't you? I think your chemistry teacher needs to talk about this more, doesn't she? Okay, let's say it. Neutrons, neutral. What does the term neutral mean? Anything will actually work for it, right? It doesn't have any sign. So that means it can be either positive or it could be negative. Right? Now, we talked about charges. Let's talk about the other variables over here, other alphabets that you can see. How about R squared?
The distance between
The distance between the two charges. Now we are just recapping back into your year 12 lessons. Year 12 and year 11, you were already introduced to electrostatics. You already knew about Coulomb's law. However, we tend to forget this when we move to the other level. Why is that so? We think it's complex. Right? I'm pretty sure you did get a little bit scared when you heard the term electrostatics. Same thing happened, of course, with me when I was a student. So don't be scared. It's normal. Isn't it? Okay. Now, we have talked about the formula. What does this K over here mean? K. I have never seen this. Have you ever seen this K?
Yes.
Yes. Where did you see this K? In the formula. Great, you saw it in the formula. So you're very observant today. And what do you think this K is about?
Coulomb's constant.
Coulomb's constant. Okay. If you say it's Coulomb's constant. Now, if you're talking in terms of Coulomb's law, you're saying this is a Coulomb's constant, that means it has a value, doesn't it? What is the value of K?
8.99
Very good, 8.99 times 10 to the power 9. Okay, seems like you're the smart one today. Others are a bit lost. Would you like to tell your friends how you got this? Because they seem to be a little bit lost during the class and not responding. I wouldn't, load you up with tons and tons of homework. If I give you another homework assignment to go back and find about K, you'll say leave it, the other friend will do it, and I'll copy that. Would you want to explain it to your friends? How did you get that 8.99? Where did you see that? You must have seen it somewhere. In the formula sheet, okay. And where did you get the formula sheet from?
You give it.
I gave it, okay. It was in the formula sheet that I gave it. Absolutely right. And we'll talk more about K in your next class where I'll show you how to derive the constant, K constant. Right? There's a long, not really long, a very simple way of deriving K in which you will get introduced to this new term. This is something new to you. Have you ever heard about this? Any idea what this is? Epsilon naught, something new, right? This will be very interesting in our next class. When we go over something new like epsilon naught, permittivity of free space. Something new, and you will see how that is related to K. Where did this K come from? Let's find it out, right? Let's dig it. Physics becomes interesting when you dig out the dead things over there, When you go to the grave, you actually dig out and find out what's happening inside. Like the archaeologists do, they go and try to find out what was there. Similarly, we physicists do that. You are all physicists because you're learning about physics. You're passionate about physics. Great, so we have briefly looked into electrostatics, we have looked into Coulomb's law, we have stated the mathematical expression for Coulomb's law. Right? Now, would you like to give me the theoretical way or to explain Coulomb's law? How would you explain it in words? I know physics is about numbers, it's about alphabets, but sometimes you need to understand that words also define physics. It's both ways. In your maths, you just have numbers. Physics, you also need words to complete your numbers. Who wants to go ahead and talk about it? Give you 2 minutes, discuss in your group, and come up with a good idea. If you want, you can sit with your friend over here. Come. And discuss about it. Just discuss how would you say it in words. And make sure no noises. You are to discuss very quietly and politely so that others don't hear your answer. Okay, so the group discussions are done. Let's see what you have from the other side. Maybe you can talk or you can go up and present. I want to see my students go, why is it just me talking? Come on, let's integrate modern ways of teaching where you talk and listen. Right? Isn't it? You can speak up. What do you think is this equation? This function? What did you discuss? Aha, I think I should have more presentations during the classes, right? Group presentations. Then you'll become more stronger to speak.
Yes.
Yes?
Yes.
Okay, you help your friend out there. What do you think is this?
Explaining
Yes, you did explain it in mathematical expression. Now I'll need you to go over into its.
force experience between the pictures as proportional to the Z1.
Right.
Proportional to the product of the Z1 and Z2.
Okay.
Inversely proportional to the square distance between them.
Very good. We need to clap for him. He actually took an effort. Very good. That is absolutely right. Good boy. You're on the track. And yes, that is the definition of Coulomb's law. The force is directly proportional. How do you know it's directly proportional? Going back to your learning. Those on the numerator, directly proportional of the equal signs, right? And those in the numerator and denominator, they're at the opposite places. So that means it is inversely proportional. And always be careful of the equal sign. There needs to be an equal sign for you to define it as a proportionality. Otherwise, you cannot state that. Now, since we are left with only a few minutes, and very soon the siren will go for your assembly. We're having assembly today. I have no idea what is this assembly for. Maybe to do with some discipline issues. But yes, let's just draw this diagrammatically. Who wants to draw this expression for me? Who wants to show me that, okay, I have two charges, there is a distance between them, and there is a force acting on them. Because, you know, right, physics, imagine. It's unlimited imagination. How far can you imagine about it? Who wants to go and try that? My gentleman is tired of trying that.
Yes.
I need the ladies to go up and to show that. Okay, the siren went, so we don't have much time. However, your assignment, what is your assignment? Assignment number 1, get these definitions. What is static and what is dynamics? And assignment number 2, homework assignment. I want this diagram to be shown tomorrow. You may know. Thank you.
Thank you,
Make a line and move for your assembly. Form captains, take charge.